A little bit about this project. I started messing around with Canvas about a year ago. Started making video games because I'm a nerd and I love to play games. I thought, well, that'd be cool, be able to make some. I don't know any relevant languages to build video games, but I am a JavaScript guy, so I thought, oh, well, I'll try it in Canvas. So I messed around with a few simple things like Pong, breakout kind of thing. So, well, I'm going to try my hand at Zelda. So the disclaimer I'll make about this project is that it is not done. And I will also ask that if you work for Nintendo, which I do not, please leave the room for the next 30 minutes. So I do, however, I work for a company called Vertifor. They're a software company in Michigan. We build Angular applications for the insurance industry. So yeah, I am from Michigan. I'm a Detroit Lions fan. So feel free to buy me a beer, because that's our coping mechanism. This is a picture of me many, many years ago as a weird high schooler trying to explain to my mom how cool Hyrule is. I don't think she cared. So like I said earlier, here are the slides. So tinyurl/Fluent Zelda. You can play the game. You can just ignore me and play what I have and find all the bugs that are in there. You can also check out the code on GitHub, which is poorly annotated, but that's okay. That's why you're here. Feel free to fork it, play it, do whatever you want with it. I don't care. I also wrote an article for AirPair, which some of you may have heard of. They are here in San Francisco, talking about the development process of the game as well. So feel free to check that out. Okay, so here's what we're going to look at. Some of just the basic concepts of game development. We're not going to go too much into the Canvas API. We're going to hit a few basic things, and then more so show what we can do with it rather than how to do it. And then afterwards, hopefully you can go back, you can talk to me or look at the code and piece some of the things together. So most of the work for working with Canvas actually happens in JavaScript. You really don't need a whole lot of HTML. Oh, by the way, I'm using an NES controller to control my slides. Thought that was pretty novel. So in this example here, I have one HTML5 tag. It's Canvas, give it an ID, a size, and then in this case, I can give it a background, which would point to the map. So that's all you need on the HTML side. Then to draw to the canvas, there's two simple things we're going to talk about today. One is you can do geometric shapes, so this would be how you could draw a square. And the function is called fill rectangle. So the thing to keep in mind is that the coordinate system is a little bit different from how you would think of like the Cartesian graph, right? So the origin 0, 0 is at the top left, and then it renders left to right, top to bottom. So just the same way that the browser would render content in the DOM. Also, I don't know if we have Q&A time or what, but if you have a burning question, I guess feel free to just interject. Okay, so from this, let's take a look at what we have in the game. So this is the game. How many have played this game? Please tell me you have all played this game. That was a prereq. Knowing Canvas was not. Yes, okay. These are my people. Okay, we have 3 Canvas elements. One for the menu, one for the game itself, one for the controller. The controller doesn't actually work on a desktop, because it's not a touchscreen. But if you go to this on your phone, if you have an Android or iOS device, it should work, but we're going to use this one instead. Okay. All right. So the first thing we're going to look at is the background. So we have somewhere to render content to. The background, which, as we see here, actually, let me close this slide. We don't need that anymore. Okay. So here's the background. It's applied in CSS to the Canvas element, but what it actually looks like is this, right? So this probably came from Nintendo Power 25 years ago. So what happens is there's a little viewport that I believe is 256 by 176 pixels, and then as the screen moves, as Link moves between area to area, we just shift the background underneath it and expose it in the viewport, right? So if we go back here, back to the game, so we're going to walk up. Ooh, yeah, that's pretty cool. Okay, so one of the things I'm going to show you here is I know this, I have this memorized because I've played this game 1,000 times now. So if we go up one screen, left one screen, there's a shop. Buy something, will you? Sure, why not? So just to show you guys that the background doesn't actually have an effect on the game, let's turn this off if I turned the wrong one off. Doing it live. Okay, cool. So I'm gonna do the same thing if I can remember where all the rocks are. Okay, all right. Up one, left one. This is really sad. Right somewhere here? Okay, cool. So the background didn't actually have an effect on where Link could and couldn't move. So you might be asking yourself, what does control what he can and can't do? That's a good question. So collision detection, anyone who spent any amount of time playing a lot of video games like me, you've probably heard the term collision detection or hitbox. So if we take a look at one of the individual screens, it's broken up into 16 by 16 pixels. And then what I did, I'll show you this here. So actually, let's do this demo first. All right, what? No, okay. So I made a map editor, and this essentially has inputs which overlay the background. And then I have different numerical values which represent what happens when Link tries to go there. So if it's a 1, he can walk there. If it's a 0, he can't. Anything higher than 1 triggers a special event. So in this case, a 2 means, hey, you're going into a cave. 3 means you're leaving a cave. 4, I think, means you're going into a dungeon, right? So I started doing this by hand and realized that was a terrible idea. I will say that I was doing this over my lunch break, and it was really, really depressing. So I came up with this editor here. Actually, let's see here. Okay. So notice how when I walk to a different screen, the values change. And then I could just go in here and say, oh yeah, just change these to whatever. Yep, I broke something. And then come down here, build map, and then I would essentially just copy this two-dimensional array and keep a massive collection, right? So this 6, 6 corresponds to where you are on the map relative to 0, 0 being here on the mini map. And when I say I did a lot of this, I mean it. So, okay, here's this collection. Yeah. Okay, now I typed all this by hand, so you guys are going to watch me scroll through this thing. Okay. Awesome. Okay, so let's talk a little bit about the hitbox. So now I'm going to live code, and that's always dangerous. But let's see how that goes. So Link has a size and a center point, and that kind of keeps track of where he is in the game. And then based on his center location, that's how you can determine, oh, well, he's here, so he's allowed to walk in this space, or he has run into something. So what I'm going to do is turn on the hitbox. And hopefully Grunt is running. And let's come back here. All right, you guys see that? You guys see the game screen okay? That's the most important thing. Awesome, okay. So you can see he's got a black dot kind of right there. And then he's got a blue rectangle and a red rectangle. And so those determine, this is really just a visual representation of, okay, you see that as soon as I hit here, bam, that collision detection gets picked up. So, okay, well, you've hit a boundary, you can't go any farther. And then there's also this like half, you can see the blue one's kind of like a half box and kind of provides some sort of depth perception. So that's how Link can walk in front of these rocks. Okay, let's turn that off because that is annoying to look at. Nope. Okay. All right. Back to the slides. So here's where one of the other Canvas bits come into play. So you guys probably heard about the request animation frame function yesterday if you went to the workshop, and if you haven't, that's fine. Basically what it does is by calling that, it triggers the event, the browser says, hey, we have to render something to the canvas. So what the browser tries to do, good browsers anyway, I don't need to tell you which ones those are, we'll keep it around 60 frames a second automatically for you. So this is just a very, very simple code snippet where we're going to request the animation frame and then pass the function into that which we want to get called as a callback when it's done, right? So it's just going to go over and over and over. And for each of those iterations, we're going to look at everything in the game, all the elements, and say, okay, has any of their states changed? If so, we need to update them. Okay, now that we've done that, let's re-render everything to the canvas. So when I'm just standing here like this, it doesn't really look like anything's happening, but there's actually 60 iterations per second over all the game code. And to demonstrate that a little bit better, I've got a fiddle, which the source code behind this isn't too exciting, but you can kind of see it's showing you the frame rate per frame and then averages the frame rate over the last second. So Chrome's doing a pretty good job of keeping this at 60. All right. Sorry, I need some water. So each of the elements that it's looping over are what we'll call game bodies for this exercise. So I took the old man in the cave, and old man is not me being mean. That's what he's called in the manual. If you don't know where he is, shame on you. He's on my shirt. He's also in this cave. All right. So what's he doing? He's doing nothing. He just stands there and gets drawn. All right, let's take a look at his code. So he has an ID. So what I use this ID for in his draw function is we get a reference to his sprite. And then we use draw image, which is the other function, canvas function we need to worry about. I'm going to say, okay, I want you to draw this image. This is the location I want you to put it at. He has a position. He has a center point, and then we're going to subtract half his height and half his width because it's going to try to locate him at the top left of his sprite. So we need to shift him up, so we draw him right at the center. So to show you that in the DOM, which may not be that exciting, but we can see here there's just all these image tags, and I probably should have made a sprite sheet, but I got too far and I kept splitting them all up. So each of these represents a different state that one of the characters can have. So back to the script here. So he has a size, which meant we had mentioned most of the things in this game are 16 by 16, and then he has a center point. So for each iteration of that loop, we're going to look at the update function of everything. In this case, nothing happens, and then we're going to call the draw function. So like we had said earlier, we get the sprite image that we need to draw and render it. So nothing really too interesting happens here. I just wanted to show this to you guys because this is the basic concept behind all of these. So if we were to look, for example, back here, all the objects follow a very similar structure. So if we look at, well, you probably can't read that. So if we look at the red Octorok, it's a very similar layout, right? So it has a draw function and an update function. And this update function is a lot more complicated because this enemy moves around, it changes state when it does, it can shoot, it can take damage, it can deal damage. Okay, so let's build on top of that. So when Link walks into another screen or a cave, a cave in this example, we have to say, okay, what are the elements that we want to render when we do the screen transition? So we're going to go back into the cave one more time so you guys can kind of see this. This is why I wore the shirt. I hope you guys like this shirt. Thumbs up. Okay, cool, yeah. Okay, so by walking in here, we saw, let me show this background here. Let me do this. Okay, so we said background means nothing. Okay, so this is your blank slate when you walk into the cave. We see a few things get rendered. The text, that's irrelevant, it's just a span. We have two cave fires, the old man, and the sword. So this is kind of how I've got it structured in the game. So when you walk into that cave, we say, okay, go get me the list of everything that needs to render, and it calls a constructor for each of those and puts it at the particular location. Right? So I could, for example, let me see. It's dangerous to go alone. Right? So like if I wanted to move this guy, right? Okay, we're gonna move you, old man. I don't like where you're standing. Come back in here, refresh, go into the cave. No, it's dangerous to stand by the fire. That was not planned and that worked out well. Okay. So people good with that? This is a collection for the particular screen. That's what we're going to render. When you leave the screen, those things get decommissioned, they get deconstructed and removed from the state of the game. I have old school notes here. Okay, let's talk about sprites. So I'd mentioned that I failed to do a sprite sheet, mostly out of laziness. But every character, enemy, object, weapon, everything in the game that's not part of the background has a sprite. And that's the image that you see when it gets rendered. They don't actually have any effect on the game either. And like we had said, they all have a center point and then a size so that we can determine their hitbox. So this is Link's pretty small set of, hey, I'm walking and I'm swinging my sword. So from those 12 images, we're able to do a lot with them. So if I go in here, see it's pretty fluid, it looks pretty decent, but there's actually only 2 images and they're just getting swapped every so often. Right? So just to show you guys a couple things, like what if, for example, I'm going to shrink this down a little bit so I can. Okay, so I want Link to walk backwards, but I want him to function like normal. So let's just swap these sprites out. Basically all I'm doing is inverting the sprites that get rendered. Okay, getting this Michael Jackson on here. Just gonna moonwalk into the cave. Okay, and then he turns around to swing the sword because I didn't swap those sprites. Okay, but that didn't actually do anything. I could still play the game. I could go over here. There's some enemies, and I could still do this weird attack. Right? Okay, let's revert that. So the way that that state gets maintained is I have my code pointer here somewhere. Okay. Nope. Okay. So right here, so what I've called a sprint cooldown, or a sprite cooldown, because I'm terrible at naming things. So every 6 frames is when Link is going to switch between his 2 sprites. And then if you change the direction that he's walking in, or you swing your sword, it's going to reset that. So to show, this is more just a fun thing. So if I change that to 2, that means his sprite is going to swap more frequently. And so he's going to do this, right? Or the flip side would be like to give him the, if you guys ever played like any of the old hockey games, kind of the same effect. So you could do this with his sprites, but speed up his velocity, it would look like he's skating. Okay. Oh, and then like I had mentioned his velocity, so move right here. So he's going to move 1.3 pixels per frame. And that was just kind of me playing the actual game on the NES and just kind of tweaking it to find a decent spot. So let's change it to 4. Okay, so what's going to happen now is it's going to go a lot faster, right? Right. The screen transition is still pretty slow, but this is hard to control. Okay. Okay, so now that we've covered that, let's talk about collision detection with some of the items or some of the enemies. So here is a really basic example of, again, I can't hit this point hard enough. Every object has a center point and a size determines whether or not they're colliding based on essentially like, do these squares intersect? So for each iteration of the game loop, what we're going to do is we're going to take any 2 things that can have an interaction. So say, okay, find me a Link, loop over everything in the game. Is he colliding with any of those things? Did he walk into fire? Probably needs to take damage. Did he run into an enemy? Maybe he needs to take damage. Is he swinging a sword? Because if so, he needs to deal damage. But wait, what if he's facing the wrong way? Right. So that's when these things they get a little more complicated, but you have to take them all into effect. But that loop provides you the opportunity to say, okay, no, I need to check all these states before you start drawing stuff. And then if you played the original game back in the old NES, it had very limited power, right? So it could draw maybe 6, 7 enemies before it would start to slow to a crawl. That's because it's doing all those calculations before it draws the next frame. So one thing we'll show later is that it's not really an issue for the browser because modern computers are a little bit faster than they were 30 years ago. Okay. Now we're going to do some cheating stuff. So I also stole the name Game Genie. We're going to talk about hacks and some codes. So, show of hands, who knows what that code is called? Shout it out. I love you guys. So here's a fun fact. That code was originally put in by Konami, not as a fun thing for players, but as a way to speed up testing, right? So if you think about it, if you're trying to test the third or fourth level, okay, well, Contra's really hard, so I never make it to the third level. So if I can give myself 30 lives, then it makes it a lot easier. So I try to do the same thing with my game, but instead of using cheats essentially from the controller input, we have the DOM to work with. So some of the stuff we'll show off here is I have a flag that turns off collision. So say, okay, I don't actually want that at all. So I'm just going to walk through these rocks, and you can't stop me. And yep. So I should have increased the speed, because basically what I'm going to show here is that you can walk through anything. Because like we talked about earlier, again, the map or the background is irrelevant. So I'm just walking over nothing. So now that we've done that, I can turn collision back on so that I can trigger the event for going into the first cave, right? I can't get to the cave any faster than that. Okay, so let's do another fun thing. So hot corner. Sorry, I should have turned that off. Okay, so I mentioned earlier about the performance of the NES slowing a little bit to a crawl. So if we go here, okay. All right, so if I go to the right one screen, there are 3 Octoroks on that screen. So let's do this. Your Nintendo would crash at this point. My laptop hopefully will not. Oh, okay, the other thing I'm going to do is I'm going to turn on invincibility. Oh, and I'm going to give myself the sword because I'm tired of going into that cave, right? Okay, so I didn't go to the cave, and I have the sword now. All right, let's walk over here. So I spawned like 100 of those things, but they all have the same starting location. So watch this beautiful, wait for it. Yeah, there it is. Okay, so now I'm just going to, right? And the browser handles it pretty well. So this, I actually was doing this when I started development because I wanted to know what's that threshold for performance? How much can Canvas actually handle in that game loop? So I suppose, okay, well, let's just spawn thousands of these things and see what happens. And this is what happens. And they all actually do a pretty good job of, moving and not crashing the browser. Let's see, what other Game Genie things can we talk about? Okay, let me undo this because that's just not good. Okay, I would hate to commit that. All right, so one of the other things we can look at with the Game Genie is, so there's a flag here on Link in this prototype that knows whether or not he has a sword, right? So when the game starts, it's set to false. And then when that collision detection picks up, oh, you're in the cave and you've collected the sword, then we toggle that to true. And we could do that in Game Genie as well. Is that my 5-minute timer? Sure. Okay, so now I have the sword. I didn't have to go in the cave. And then if I actually do go in the cave knows to look at that flag and doesn't draw the old man or the sword. So they're gone into the abyss. Okay, one of the other things we can do is, say I want to give myself a lot of rupees. So yeah, let's do that. And then actually, I want more bombs too, because I don't want to have to find them. Okay, so now I've done that. And then by changing those inputs for each iteration of the game loop, it's going to look at those DOM nodes and see, oh, okay, well, this value has changed, so I need to update in the game state as well. So I can equip the bomb, come in here. Okay, what's in this cave? Oh, it's a secret to everybody. See, you didn't know, because it's a secret. Okay, so I'm going to pick up my rupees here. Okay, the cave does not maintain its state. There's one of the bugs. You can mark that down. Someone submit a PR. And then I'm going to come over here, and I'm going to buy the blue candle. Okay, cool. Now I have the candle, and now I can shoot fire. And now I could go kill 100 Octoroks with my candle if I wanted to. All right. I think that's a pretty good snippet of what we have to talk about, and it is getting close to lunch. So what I'll do at this point, like I said, I am on the Slack chat, at Rich. I was the first Rich to sign up, probably not the first Rich at the conference. And there's a link to the slides as well. If you guys want to talk more about Canvas, you have questions, you want to talk about Twilight Princess HD, come find me. But yeah, hopefully this helped. This was really to show you not so much like, I'm ready that I can code everything in Canvas. Just wanted to show you this is what it's capable of doing without any third-party libraries. I'm not an animator. I don't know anything about 3D graphics. So we didn't use any of that. No ROMs, no emulations, just JavaScript, because that's what I know. So hopefully you guys feel empowered now to go back to work on Monday and embed this in your application somewhere. Yeah. Yeah, you can come chat with me while I'm unhooking. Yeah, for sure. Okay, thanks everybody.